So check this out. This is my implementation of flow field pathfinding using Unity. So this is like my little game world. It's a 3D world, but I've just used a two-dimensional plane here, and I've just kind of built a simple level here. The green is sort of like grass or just kind of passable terrain. Here, these blocks are like, you can imagine them as being like mud or something like that, like kind of a terrain that you would like go a little slower walking over, you know? And then these red ones, you can, or sorry, these black ones, you can imagine these as being like impassable terrain, so like a wall or something like that. So this is sort of like just a basic kind of sandbox world. And basically the idea here is that I've integrated a flow field into this where units sort of on the game world can find a path to a destination and find the most optimal path to that destination. So how I've done it here is if I start the game world, the first thing I've done is I've broken the world up into a grid. So here I'm just showing you the grid. You can see how there's, right, it's broken up into a bunch of cells basically. And on each cell I assign a cost. So the passable grass terrain is just like has a value of 1, and the impassable terrain has just a really big value. And then the mud, I just gave it 5. You know, it's just a cost that it costs a little bit more to walk. You know, from compared to the grass, the mud's a little more difficult to pass over. So there's a cost on each of the grids. The next thing is called an integration field. So basically, right now it's a separate cost associated with each tile. Right now it's just set to a super high number. It's independent. It hasn't been calculated yet. So what I'm going to do is I'm going to click kind of anywhere on this grass, or from the center of my screen I'm going to click, and what it's going to do is it's going to calculate an integration field based on my goal. So my goal is where I click that 0 right there, and basically you can see how there's numbers sort of radiating outwards, and that's the cost from that tile to get to the goal tile. So you can see how, like, for example, 5 over there, it's going to cost 5 movement in, you know, movement units to get to 0. And you can see how, depending on where I select my goal to be, it will calculate a different sort of integration field for a cost to get there. And as you can see, like, it'll factor in like the mud. You can see each tile I move over, it like adds that cost of 5 to each tile, right? But then the cool part about it is this is the vector field that's created. And so if I click anywhere, you can see how it recalculates where to go. So basically what this means is that any unit that's sitting on one of these tiles will just read the direction that it's pointing, and that's the optimal path to that goal. So what I'm going to do here is I'm going to leave the target here. You can see that's my target, and I'm going to hit a button, and it's going to spawn a bunch of just units, and they're going to move towards that. So you can see how they're all following the vector field towards the goal. And so I'll click over here, and you can see how they're following that vector field to move to the location. You can see like they're trying to avoid like the mud. Like they could go through it. I'll click them onto the mud, but they're going to find the most optimal way, the cheapest way to get there, right? And you can see that they're trying to, I'll spawn a little bit more to give a better example. It kind of gets laggy after I spawn a ton, but you can see how they're trying to path find, right? And they're trying to find the most optimal way. So yeah, pretty neat, huh? It's some kind of cool. Spawn more. I haven't really tested the limits. Kind of gets laggy, but yeah, it's pretty cool. Hey, it'll just follow sort of the path based on those calculations. And this is for like typically used with like fluid kind of simulation. as you can see why, you know, because it kind of looks like water kind of moving around or something, right? But yeah, this is just one form of pathfinding. It's particularly useful if you're trying to move multiple units to one area, like multiple entities or pawns to one place, because you just calculate one flow field and then everything just reads from that flow field as one calculation, compared to having to calculate a unique path for each individual, you know, pawn. And as you can imagine, that becomes like very intensive. There's also bugs, you know, it's going over the impassable terrain. That's because I think they're kind of pushing each other onto it. It's because they actually collide with each other and they're kind of pushing each other onto the impassable terrain. But yeah, it works pretty good, like just in the sense of, you know, that it's kind of following the rules for the most part there. Yeah, cool stuff.